So here in this given CFG, let's represent this CFG as G. If we have to find out the different tuples, as we know, the first tuple is S, that is your starting symbol. So here the starting symbol will be based upon the starting production. So this is your starting production. The very first production will be represented as the starting production. So A will be represented as your starting symbol. Coming to the set of variables are represented by capital symbols. So just look out all the variables that are present here, that is the set of capital alphabets. So we have A, we have B, we have C. Then coming to terminals, the set of terminals are digits, small alphabets and your special symbols. So small a, B, and then we have C, D and star. So these are the set of terminals. And coming to P, we have around 2 productions here, 2 productions here and 2 productions. So we'll simply write the 6 productions together and we'll say that these are the set of productions rules. Now coming to the other concept, that is called as derivation of a string. Take a very simple example here, and this is the starting symbol of the grammar. This is the production of the grammar. We can also write it this way. Now when it comes to deriving a string will always consist of terminals and it will not have any variable into it. So if I have to simply derive a string, the simplest string here will be S represents epsilon, and this is called as null string. This is the first string that has been derived by the grammar. Then coming to the other strings, so for that we need to take this production, otherwise this is not going to give you any further enhancement in the string. So we'll take this ASB. At the place of S, in the next step we can simply put epsilon and we'll get the string AB. So this is the next string, and we know that A and B both are small alphabets, so we can say that this is the next possible string. Now deriving the other strings, we'll again take this particular production ASB, and at the place of S now we are not going to put epsilon because otherwise it will generate the same string. So we'll put this production into S and we'll get ASBB. Now again at the place of S we will put epsilon and we'll get AA, So this is the third string. Coming to some more derivations, again we'll use ASB. At the place of S we'll put ASB. Again at the place of S we'll put AA, ASB, BB, and the place of S we'll again put epsilon and we'll get AAA, BB. So this is the third string. So if I write all the strings are epsilon, AB, AA, BB, AAA, BB. So to find out the pattern of the string, what we can do is we will derive around 5 to 6 strings and then we will generalize a pattern for it, and that will be called as your language. So here we can see that we have one A and we have one B, then we have 2 A's which are followed by 2 B's, 3 A's are followed by 3 B's. So if we have to write it in the form of a language, we can simply represent it this way. L represents a language and we can say that number of A's are equal to number of B's, but A will be always before B's. So A to the power n, B to the power n, and n will not start from 1 because it is also having epsilon. So we'll start it with 0. So when n will be 0, it will generate epsilon. So this is the given language for the given CFG. So this is the CFG which is having the set of productions. This is the context free language for the given CFG, and if I have to write the regular expression for this, it is not possible because we cannot draw a deterministic finite automata for this. So in this way we have understood how we can derive the derivation of a string. Now coming to derivation tree. While deriving a string, we can also make the derivation tree for that. And how will we do that? For the first string, the derivation tree will look like this. S will give rise to ASB, and at the place of S I have put epsilon. Then derivation tree for this particular string. First production is giving rise to ASB, then ASB. At the place of S we have put ASB, and at place of S we have put epsilon. Third production is this. So this is the given derivation tree. This looks like a tree. We have noticed that the very first symbol in the tree, the topmost symbol in the tree, is your starting symbol. Coming to the other particular nodes, this is S, and all these S are internal nodes. So internal nodes will be always your variables. Your variables will be your internal nodes, and internal nodes will always have a degree, out degree. If I talk about the out degree of S, it is giving rise to 3 edges, 3 branches, A, S, B. So the out degree of S is 3. The out degree of this S is also 3, and the out degree of this S is 1. Out degree of this A is 0 because it is not giving rise to any branches. So A, epsilon, B, B, these are not having any branches. So they are called as the external nodes of a tree, or you can also say leaves. So we can find out that in the given CFG, S is always your root, and then V, that is set of variables, will be always your internal nodes, and your terminals will be always your external nodes, or you can say leaves. So we can clearly see how we can find out the derivation of a string in a given CFG, and we have also drawn the derivation tree for that. And the other concepts we will learn in the other videos. Thank you so much.